Assalamu alaikum, dear students. Welcome back to our lectures on physics, concepts of physics. As you know that in the previous lecture we were discussing the concept of circular motion or and we have already discussed the angular displacement and angular velocity. Now today we have the concept of acceleration in the circular motion. So we have to discuss the acceleration in circular motion. Now there are four types of accelerations in circular motion. In circular motion, there are four types of acceleration and we will discuss all these accelerations one by one. So here we have on the board there are four types of acceleration, that is centripetal acceleration, tangential accelerations, third is net acceleration, angular acceleration. So first of all we will discuss the concept of centripetal acceleration. So we are going to discuss the concept of centripetal acceleration. So now we are going to discuss the concept of centripetal acceleration. You know, centripetal acceleration, the acceleration which is due to change in the direction of velocity of a circular motion. The acceleration which is due to change in the direction of velocity of change in the direction of velocity of circular motion, which is due to change in the direction of velocity of circular motion. Which is due to the change in direction of velocity of circular motion. So, वो acceleration which is produced in a body moving in a circular motion due to change in its direction of motion. You know, we know in case of circular motion, when we are going to discuss the circular motion, let us consider a particle that's moving in a circle of radius r. A particle is moving in a circle of radius r, and you know that when a particle is moving in a circle of radius r, it means it is changing its direction. If it is uniform circular motion, still particle is changing the direction. So when there is acceleration, कब acceleration होती है? Whenever there is change in increase in the velocity, whenever there is decrease in the velocity, whenever there is change in direction. Three things cause the acceleration. One is increase in velocity, decrease in velocity, change in direction. If it is uniform circular motion, अगर ये uniform circular motion होगी, फिर भी इसमें direction of velocity change होती है. So direction of velocity change होने से जो सर्कुलर मोशन में जो डायरेक्शन ऑफ वेलोसिटी चेंज होती है, तो इसकी वजह से जो एक्सेलरेशन होती है, दैट्स कॉल्ड सेंट्रीपिटल एक्सेलरेशन. सो दिस it is directed towards the center of circle and is along the radius, so centripetal acceleration is v square divided by r. It is obtained, we can derive it. It is v square divided by r. V is equal to R omega. So AC is equal to R square omega square divided by R. ER cancel. AC is equal to omega square R. This is the centripetal acceleration. So we can derive this centripetal acceleration as well. We can derive the centripetal acceleration. So इससे पहले एक क्वेश्चन आया था पिछले साल एग्जाम में, derive the expression for the centripetal force. You know force is equal to mass into acceleration. So what you have to do, you have to derive the centripetal acceleration. So then you have to multiply it by mass, so you will get the centripetal force. So centripetal force, you know, acceleration according to Newton's second law, whenever there is force, there is acceleration. So whenever there is force, there is acceleration. So without force, there is no acceleration. So if there is change in direction in circular motion, if there is change in direction, circular motion में change in direction है, तो change in direction, this is because of force. That force is always directed towards the center. That force is called centripetal force, and centripetal force is responsible for the circular direct change in direction of motion in a circular motion. ये जो सेंट्रीपिटल फोर्स है यही रेस्पॉन्सिबल होता है कि ये डायरेक्शन ऑफ मोशन सर्कुलर मोशन में डायरेक्शन ऑफ वेलोसिटी चेंज करता है. तो सेंट्रीपिटल एक्सेलरेशन भी हम निकाल सकते. और ये जो सेंट्रीपिटल फोर्स है, इट्स नॉट अ फोर्स, but some force has to play its role. Itself it is not a force, it's name, it is simply a name. We call a centripetal force which is responsible for the centripetal acceleration. It is directed towards the radius or towards the center and is along the radius. But that force sometimes it may be gravitational force, because you know moon revolves around the earth. Gravitational force between moon and earth, that plays the role of centripetal force. When an electron revolves around the nucleus, there the Coulomb's force between electron and nucleus, that plays the role of centripetal force. So some force has to play its role. Magnetic force in cyclotron, that plays the role of centripetal force. So some force has to play its role. So what is centripetal force? It's name, but some force has to play its role. So now centripetal force is the cause of centripetal acceleration. So now if you are supposed to derive the centripetal acceleration, we can derive the centripetal acceleration as, for example, let us suppose we have a body that's moving in with uniform circular motion. This body is in uniform circular motion. So ये body uniform circular motion में है. तो यहाँ पर let's suppose a particle is at point A, at its velocity is v1, at point B its velocity is v2. Direction of velocity, it is the direction because only direction is changing. And you know this tangential, this tangent is perpendicular to the radius, so this is perpendicular, that R is perpendicular v2, and here v1 is perpendicular to R. So let's suppose this is angle theta. Theta is the angle between two points, or we can use them A and B as a OA, OB and OP. It's the position vector. That's if we will take the center as an origin. Now, there is a theorem. We can draw these velocities. This is velocity v1 and this is velocity v2. So this is v1 and this is v2. So we will join this. I will write it delta v. ठीक है ना? अब यहाँ पर क्या करेंगे हम? So this is angle theta. Why this is angle theta? According to one theorem, the angle between the two sides, if their sides are vectors, is always equal to the angle between their perpendiculars. अगर इनके जो परपेंडिकुलर जो एंगल यहाँ R और ये R बनाते हैं थीटा, तो इनके जो परपेंडिकुलर्स है वो भी वही एंगल बनाएंगे थीटा. सो यहाँ पर हम ट्रायंगल ऑफ वेक्टर एडिशन यूज कर सकते हैं. ट्रायंगल ऑफ वेक्टर एडिशन, दैट्स यहाँ पर तो मैं लिखूंगा अकॉर्डिंग टू ट्रायंगल ऑफ वेक्टर एडिशन, दिस वेक्टर एंड दिस वेक्टर है सेम. सो मैं लिखूंगा v1 प्लस डेल्टा v, because they are in same order. Two vectors v1 and delta v, they are in same order, and this is in opposite order, that's v2. So V2 represents the resultant vector. So delta V is equal to V2 minus V1. If this angle is very small, then we can write it dV is equal to V2 minus V1. This is in. Now we can draw here, this is radius, this is R, and let us suppose this displacement at a time, very small time dt, this displacement is ds. So I will write this ds, because now you will say that this is not a straight line, this is ds is its curve, but when the displacement is very small in a very short time, छोटा सा सर्कल है, छोटे से टाइम में इतना डिस्प्लेसमेंट, we can take it as a straight displacement, then it's not a curve because it's for a very small interval of time, बहुत कम टाइम में जो छोटा सा डिस्प्लेसमेंट होगा, that is dl. Now ये भी एंगल थीटा है. Now these two triangles are similar, so corresponding sides are similar triangles, or these are the proportional. So we say according to corresponding sides of the similar triangles are proportional. So we can write it ds. So ds divided by r, ds divided by r, ds, this is ds divided by r is equal to delta v divided by v, yeah, dv divided by v. For very small, this is dv divided by v. So we can say dividing both sides by dt. So delta s divided by r dt is equal to dv v dt. You know delta s divided by delta is 1 by r v, delta s divided by delta t, ds divided by dt, ds divided by dt is v, that's equal to, this is dv by dt is equal to a1 by v into ac. You know ac because there is no change in magnitude of the velocity. It is uniform circular motion, there is no change in the magnitude of velocity, so there is only the change in direction. So that change in direction of velocity, that causes the acceleration, that's called centripetal acceleration. And you know ac is equal to, अब यहाँ पर ये रहेगा, it implies that ac is equal to ये v और ये v square divided by r. This is ac is equal to v square divided by r. And this is how we can derive. पहले हमने डेल्टा dv निकाला, फिर हमने ds divided by dr निकाला, तो फिर हमने इन दो ट्रायंगल्स को सिमिलर किया, तो corresponding sides of similar triangles are proportional. So ds divided by delta v, आप ये भी लिख सकते हैं, ds इसको हम dv भी, so आप लिख सकते हैं ds divided by dv is equal to ds divided by vb और divided by v. तो ऐसे भी लिख सकते थे, फिर इनको ऐसे लिखो v divided by dv is equal to ds divided by r, जैसे मैंने यहाँ पर डायरेक्ट लिखा ds divided by r is equal to dv divided by v. तो इस तरह आप इसको डिवाइडिंग बाय बोथ साइड्स बाय dt, तो इस तरह ac is equal to v square divided by r. And you know that this is the acceleration now here. So इसमें हम क्या कर सकते हैं, ये एक्सेलरेशन बन गई हमें ac is equal to v square divided by r. This acceleration ac is equal to v is equal to r omega, r square omega square divided by r. तो ac is equal to ये r और ये r cancel, omega r square. And omega, you know omega is equal to 2 pi nu in terms of frequency. So ac will be equal to r omega square or, so r omega square 2 pi nu square whole square. So in terms of frequency अगर आपको ये देखना है तो ये आएगा in terms of frequency ac is equal to 4 pi square nu square r. This is the centripetal acceleration in terms of frequency. And centripetal force, you know, F is equal to m into a. So F is equal to mass into a हो गया v square divided by r. ये this is the centripetal force. यहाँ पर लगाओगे तो F is equal to m into a की जगह ये आएगा m omega square, और this is the centripetal force. यहाँ F is equal to m 4 pi square nu square r. This is the centripetal force. So in terms of frequency, in terms of angular velocity, and in terms of linear velocity. So these are the expressions for the centripetal force. This is the centripetal acceleration. This is here centripetal acceleration, and this is here centripetal acceleration. So we were discussing the concept of centripetal acceleration. And now इसके बाद एक और acceleration इसमें आती है, that's called tangential acceleration. That's called a tangential acceleration. So that will be discussed in next lecture.